Carsten. David is the co-chair of the Enterprise Expert Group. You've been working for quite some time now with OSGi, as well as Carsten. Carsten, you're serving on the OSGi board, and both of you are very active in several Apache projects, including, of course, the Apache Felix project. So, please.
Okay. Thanks, Christer. So, yes, the Enterprise R6 specs are out. They went through all of the processes that Tim described in the talk previous to this one, in this room, if you're here. And it's kind of always a lot of work to get all the specs out. But the end result is always, I think, pretty high quality. And Carsten and I are going to talk about some of the new specifications that appeared in this release. So we've been introduced already, so I'm going to skip over these slides and talk about the agenda for today. I'm going to start talking about asynchronous services and promises. Then Carsten will spend some time on declarative services and HTTP Whiteboard. And then finally, I'm going to talk about REST management and portable contracts. Okay, so asynchronous services and promises. Now, I think I'd like to start with talking about, I pressed the button, about asynchronous programming in general. So, if you want to do some asynchronous programming in terms of, let's kick off a process asynchronously. And when that's done, kick something else off asynchronously. And when that's done, do yet something else. That is actually not so very easy to do in Java. You can write some verbose code that maybe uses a future or something like that. But it's not very easy. And especially the future that is part of Java 5 doesn't really give you a callback mechanism when the thing that you invoked is finished. You have to poll, which kind of defeats the purpose. So, on the other hand, JavaScript has a nice model which is widely used, which is called promises, which really kind of gives you the ability to register an operation that you want to do, and then you provide a callback as a promise to deal with the result, whether there's a failure or a success of that asynchronous invocation. So these promises really inspired OSGi to develop similar promises that can be used with Java versions from Java 5 and newer. I do want to say that they provide a very simple programming model. You get some sort of a waterfall model, very similar to what you get in JavaScript promises. Now Java 8 has something called a completable future, which provides something similar. Although completable future has a horrendous API, it does provide you some callbacks. I guess the benefit really here is that we can use these promises with Java 5, and in OSGi we needed to be able to run on older versions of Java with these promises. Another thing that's worth mentioning is that the promises can be used outside of an OSGi framework. Most of the OSGi specs require an OSGi framework to run because they register services, for example. These promises are just a jar file, so you can use them inside OSGi, but you can also use them outside of OSGi, wherever you like. And implementation can be found in the Apache Arias project. So how does this work? What does it look like in practice? So let's say you have this method, which I have here at the bottom. I hope it's readable. Basically, the method is called takes long to do, and you provide it a long, and it returns a long. I don't know what it does, but it takes a long time. So instead of just returning a long, you return a promise to a long. And with that promise, you get a nice API that when you call this function, you can say, okay, I want to call takes long to do with the number 21. And when it's finished, I want to do something else. And that's what you can do with the then method. So I use Java 8 syntax here with lambdas to basically provide a function that is called when this long method is finished, but you could also use in anonymous classes to do the same thing. So here I say I call this method takes long to do. When it's done, I want to print an intermediate result, which actually in turn calls this method again, and then when that one's done, I want to basically put the final result on the screen somewhere. So here you have a waterfall of 3 functions that are kicked off asynchronously, and then when the result comes in, the next method is called asynchronously, and so on. And then when I'm I register this, you can see that this last line is printed out immediately. The asynchronous computation is kicked off, and my main thread of programming can just continue. So that's kind of the promises. And it
takes long to do. There you're still responsible for kicking off your own thread or something?
Yes, the promises require you to register use your own mechanism to do the threading. So you can choose whatever you want. You can maybe have a thread pool, maybe create your own thread. That's your responsibility. Now these promises are the underpinning of OSGi Asynchronous Services. So what is an asynchronous service? Well, basically, an asynchronous service is just an OSGi service that is run asynchronously. And with the async service, you can literally take an existing OSGi service and make it asynchronous. And in that case, just to come back to this question, the threading is actually handled for you on this level with the async services. So, this is really useful if you have services that are a little bit time-consuming, especially, for example, with remote services, which are always time-consuming in terms of computing. If you can deal with the result as it comes in at a later point in time, it's definitely worth using asynchronous services for it. So here's just a comparison of what it would look like. Let's say you have this service called time-consuming service. Here, I obtained it from the service registry using whatever mechanism I like to do. I mean, you can use declarative services, or you can use Blueprint, or whatever you like. So I have that service, and now I'm going to invoke it here. At this point in time, this thread is blocked, because this method takes a long time to do, and any code beyond that has to wait until it's finished. Now that's really a good candidate for an asynchronous service, because maybe you want to just throw that on the screen somewhere. So what do you do in that case? You still obtain that original service from the service registry, but you also obtain this async service from the service registry. That's the service defined by the OSGi specifications. Now that async service has a mediate method, where you can basically say, I'm going to mediate that service into an async one. Now that actually returns an object that still implements the same interface, but now I can actually give that mediated object to the async service and make a call on it that returns a promise instead of the original value. So this one, let's say this one returned a long, and in this case, this call returns a promise to a long, and now I can make this then call and say, okay, when that big task is finished, then put it on the screen. So it's basically using these promises as a way to turn any OSGi service into an asynchronous service. There's one thing I wanted to mention as well is, in the simplest use case, you just take an existing service that is implemented in a synchronous way, but there's also mechanisms provided by the specification that allow you to actually aim at asynchronous services for your service implementation. So in some cases that might be useful if you want to preserve resources or do something optimized for asynchronous usage. Okay, and with that, I'm handing it over to Carsten to talk about declarative services.
Yeah, thanks. Before I start, I have one simple question. Who attended our talk yesterday of you? Oh, it's more or less more than half. It's too bad. If everyone would have done that, I could just skip the next slide and go to vacation. Okay, so basically OSGi has two let's say, main principles. One is the module system, and the other one is the services, right? So you have the service registry where you can register your services, look up your services, use these nice asynchronous stuff, and then all these things. And obviously, the task as a developer or the task for a developer is to develop services and then write them in some Java code and somehow get this into the service registry. And then we think one of the best ways or easiest ways to do that is one of the OSGi specifications we have, which is the declarative service specification. And especially for R6, we did a lot of nice updates to that specification to make it even easier to develop your components and services. So this way is really a very powerful but simple way of developing your components. It manages all or most of the dynamics that might happen in your system, because services can come and go and you have to deal, and usually you have to deal with these facts in your code. And if you're using declarative services, it takes care of most of the stuff for you. And also, usually you want to be able to configure your components in some way, so you want to integrate with the configuration admin, another specification in OSGi, where these configurations are stored, and you want to get this configuration for your component and use it in your code, and then other things. And I think with the R6 version, we've reached some, which I think nice goal, is if you develop your services, you can do that 100% in Java. There's no other, let's say, configuration file or property file that you have to write. It's all done in Java, which I think is pretty nice, because you have one place to go. All right, so we have a set of annotations you can use in your code to develop your components and its services. And for example, if you just want to develop a service, you just use this component annotation on your class, and you're done. And this annotation is processed at build time. It generates all the required files, puts them into your bundle, you deploy your code, and you end up with your service automatically registered in the service registry. In this case, it would be this game controller thing. Then when it comes to configuration for your component, you can simply do that by describing this configuration set as an annotation. So you write your own annotation class. In this case, I've just this config annotation, which lists all the different property configuration values for your components, together with a default value. Right, and then you can just, in your code, implement the lifecycle method, which is the activate method that you annotate with the activate annotation. And when your component gets activated, this method is called by declarative service implementation, and you get the current configuration for your component, and this configuration comes from the configuration admin. Obviously, if there is no configuration, you get an instance which has these default values. So you can just simply use them. And it does all the type conversions between how the stuff is stored in configuration admin and how you want it. For example, you want an integer here. It might be stored as a string, having a number in configuration admin. The DS declarative service implementation takes care of all this converting. Then the other thing is, if you want to have a meta type description, again another OSGi specification we have for your configuration, you can simply do this with an additional set of annotations, and you simply annotate your configuration class with these different annotations. So you give it a nice name, a nice description, you describe each property with a name and description, and use this designate annotation to bind this meta type description to your component. And once you have this all done, deploy your code or your bundle into your running system. You can then simply use all this information. Yes, please. Oh, it's okay.
What the designate annotation is.
Right. This ties the so this one is just a meta type description for this configuration set, for this config object, let's say. And you somehow have to tell that your component, this game controller, is using this meta type description. That this belongs to your component. And that is done by this designate.
So for the previous step, you just have the activate method working, you don't need it. It's to have this
you still need it. You still need it. Because you might have you might not have this activate method, right? And then it gets complicated whether you have to write it or not. So we said always use a designate annotation. Right, and then once you have this configuration meta type stuff, deploy your bundle into your running system, you might want to use the this meta type description at runtime. One way, for example, is the Apache Felix Web Console, which uses the meta type description to dynamically generate a nice web-based form to configure your component. So it uses all these labels and descriptions and the default values. And
one question.
Sure.
So if I have a handoff to the config admin and I know the PID of that service, I would still send in that dictionary, string object dictionary. Right? I wouldn't create the config object, but I would still create the dictionary as I would do today, right? And then the conversion happens before it reaches my activation.
yes, exactly. Yes, right.
Yeah. And I will see if I made a type error, it will be propagated to me. Then I do the update on the config admin, right?
Yes.
That's how it works.
Yes, exactly. Yeah.
Thank you.
Right. So whenever you change something in the config admin for the configuration of your component, the component gets updated with the new values. It all works, and you don't have to deal with that in your code. It just magically works. It does. Then the other interesting thing are references to other services. So you want to use within your component other services maybe someone else wrote. And when it comes to declarative services, there are different ways to get hold of a different service. With previous versions, we had the lookup and then event strategy. Usually people use the event strategy, which meant you had to write a bind and an unbind method. So whenever a service which you're interested in was registered in the service registry, a bind method on your component was invoked. And the same happened when this guy disappeared, which is a lot of boilerplate code you have to write. And we thought, okay, we can make this much easier, and came up with this field strategy, which basically gives you field injection. So you can simply annotate a field in your implementation, which is a reference to some service. When a component gets activated, this field gets automatically filled with the existing service from the service registry. Of course, there are different configurations you can do on this annotation to handle the dynamics, whether you require the service, if it's optional, and all these things are dealt. You can simply do that with the reference annotation, which is kind of handy because it takes care of most of the dynamics happening in your system. You don't have to worry about that. And the other nice thing is we have a runtime service, which gives you a set of DTOs, which represent the current state of registered components and the references, their configuration properties, whether they are active, whether references are satisfied, and so on. Because what happens what happens sometimes, let's say, is people develop their components, deploy their bundle, but they don't see the service in the service registry, right? Because there's something wrong. And then you need to figure out, okay, what is wrong? And a nice way is to simply look at these DTOs. And for example, we have a plugin for the web console. And then you can find out, for example, this service has an unsatisfied reference. So it's requiring another service, but then that one is not there. And then you can find out from here, well, that one is not there, and go through the system and see what's happening. And this is basically a very, very brief introduction what we have new in R6 for the declarative services. I think there's a talk in the afternoon by BJ, which covers the whole DS specification. So this is just a peek for that one. And yeah, as I said in the beginning, this is really a very simple but effective way to develop stuff. For example, we use that throughout our products, and we have hundreds of developers, hundreds of bundles, 10,000 of components. That really just works nice. We can cover, let's say, 95% of the use cases with DS. Yes?
Have there been discussions about method level injection in some way? Because I think it's a bit tricky to do it with a lifecycle model, to do
I'm not quite sure what you mean, but what you can do
We
with...
have the bind methods.
Exactly, yeah.
This, that's the event strategy. Now
Right.
we have field injection, and well, my feeling is that the next level would be on the method level, that you have a logic that you're executing in your component and a parameter to it, and you want to inject the parameter as well through a service. But I think the trickiness lies in the life cycle of the component you're trying to manage. If you declare a reference to the method parameter, you're out of the woods somehow. So I'm thinking
Right.
about it. Has this been discussed, or
Yes.
have there been some ideas about that?
We've discussed this several times, and we always came to the conclusion that it's too hard, or let's say too complicated to do with get this right with respect to the life cycle of the component, because you have to then undo things and all this stuff, and it gets too complicated, and the effort is not that high. Right. So yeah, as I said, DS is really a very nice and simple thing. The other thing we wanted to present is a new specification we have, which is the HTTP Whiteboard service implementation. So this basically gives you a way of developing a web application in an OSGi framework and write your own servlets, filters, listeners, and all these things as services. And you register these services in the service registry, so you register your servlet. It gets picked up by this HTTP Whiteboard implementation, and then is active and can be called through requests. So for example, if you have your web application running in an OSGi framework, which consists of these three servlets, matching these paths here, you have some resources for JavaScript, CSS and whatnot. You want to have some servlet filters up front, which are called, and maybe some request listener for whatever reason. So this basically makes up your small little application. And if you now want to use the HTTP Whiteboard service, when you develop your components, and again in this example I used declarative services, you simply register this thing as a servlet service and specify some properties, like the most important one, the path of your servlet, where you can reach the servlet. The same is true for filters. You register your thing as a filter service, specify the pattern, deploy your stuff, and these things are active and do something whenever a specific request comes in. And just to show the other example, the same is true for listeners. If you want to have a request listener, you register it with that interface. You have to specify this opt-in property for listeners, just to mark it that it should be picked up by the Whiteboard service. That's all you have to do. So that's really a very simple way, or easy way to get servlets and all these things running in an OSGi framework. Now the interesting thing is, we are now, obviously OSGi is about modules, modular system and so on, and sooner or later you want to run this web application within your OSGi framework from someone, and another one you get from someone else, because you want to have those two functionalities within your whole application. So someone else came up with a second application. It's using servlets and so on. And the interesting thing is you now have some clashes here, because you have a servlet here registering for a request. You have resources for JavaScript, CSS here, the same over there. And obviously you have to deal with this clash. And we came up to introduce the known concept of servlet contexts in the Whiteboard stuff, so you can basically group your things based on servlet contexts. So you register a servlet context for each application and give it a path. And then this means this application is reachable underneath that path. So for example, if you want to call the game servlet over there, it's /play/game, and similar on this side. And to register such a servlet context, you must implement a very simple service, which we call the servlet context helper. It's not the best name, but we talked about that 3 weeks seriously and came up with that name. And yeah, it has this properties, so you give it a name, a unique name, and a path, which is this path prefix. And then in your servlets and filters and all your web components you write, you have to reference that context. So you specifically say this servlet belongs to that context by referencing it through that name this context has. And apart from grouping, this thing has some other things, like for example, you can handle security, authentication through this context, resource handling, and so on. Provides all these other things. Right, so we have finally a way to use the latest Servlet 3.1 specification in an OSGi framework. We also have a DTO and runtime service, so you can find out which servlets are registered and which filters and all these things, which is pretty nice for introspection. And that's pretty cool to develop your stuff with this thing. And with that, it's back to David for the next part.
Okay, let's take a rest then.
That's good.
Oh no, it's about management. She's taking a rest. OSGi and remote management. There's already some remote management specifications available for OSGi, such as JMX management, DMT admin. Why did we come up with REST management? Now, the problem was that JMX, we really wanted to have a nice remote management mechanism that worked well in the cloud. And JMX, the remote JMX management doesn't really work so well in the cloud. Like it uses RMI and opens ports back and forth, and typically that doesn't work very well in the cloud. The other one that's available is DMT admin, which I'm sure works perfectly fine, but it's really coming out of the embedded world and is not very well known in the enterprise world. So there was really a good case for a simple REST-based management mechanism that allows you to do things like, control bundles, install them, start them, stop them, look at your services, maybe change some start levels, do some basic framework management. Over HTTP, where the data is either in JSON or in XML, or you can also come up with your own format if you like. So the OSGi REST management specification provides this. It also so it allows you to do raw REST over HTTP. There's also a Java and a JavaScript client which give you a nice programming interface. And I put a link to an open source implementation at the bottom where you can get a working implementation to try this out. So what does this look like in practice? I just put some examples here because I think that's just the easiest way to explain it, and I used curl because it's a very simple way to make HTTP requests over the command line. Obviously you can do the same from a browser. At least you seem to like curl. So, let's say I have such a REST management service running on this machine, localhost, some port. If I want to find out what bundles are present in my framework, I can just issue a GET request on the framework/bundles URL, and that gives me URIs for the bundles that are present. The next one is a little bit more interesting. If I want to install a new bundle, I can actually do a post with the binary data of the bundle as the message body. In curl, it looks like this. It's a little bit of a convoluted command line, but you get the idea. You post the content of your bundle in the message, so you don't have to reference a URL that is accessible over the internet. You can just post the data. You need to specify a content type header. But this will basically install that bundle, and as a return value, it would give you the bundle ID of the newly installed bundle. And then you can basically obtain bundle details by looking at the bundle URI, and it will tell you status 2. Now, that may not be too descriptive, but you can look up that 2 means installed. I have 5 minutes left. And then, so the next thing you want to do is you want to start that bundle, which means you want to move it to state 32, which you can do by issuing a put on the state. So these are just some simple ways, some examples how you can use this REST management specification to control bundles. I put one more in there if you want to list services. There's a similar to the bundles URL, there's a services URL, but in here you can also provide a filter. So let's say I want to see if there's a resolver service present in this framework. Then you can say, okay, I'm going to add a filter that says object class equals star resolver, because I forgot what the prefix is, but I want to see the resolvers. And yes, it gives me a service URI, and I can use that in a similar way to introspect it, see what its properties are, and so on. There's also 2 clients, as I briefly mentioned. I won't go into it too deep. There's a Java client, which gives you a nice API to make the same calls under the hood. It's exactly the same, but if you're programming in Java, this might be a little bit nicer. And the same for JavaScript. You can obtain an OSGi REST client and call get bundles. You get a callback promises style now in JavaScript, and you can do something with the result, which is the array of bundle URIs that is returned from the REST service. Okay, and then really briefly, I wanted to go into portable Java contracts, which is another specification which is actually not part of the spec documents. This is on a website, on the OSGi website, because it's something that keeps changing. And it actually addresses a very important problem. So there are Java packages specified by other organizations that don't follow semantic versioning. And for example, the JavaX Servlet API. You have Servlet 2.5, which is very widely used. And then Servlet 3.0, for example. The nice thing about 3.0, it is backward compatible with 2.5. But why did they call it 3.0? Well, that was probably just a marketing decision. But the problem is, if you're using OSGi semantic versioning and you have a version range that is a semantic version from 2.5 or up, it would not include 3. So if your packages are versioned 3, then they would not resolve to your code that will still, perfectly work with this. So what is your version range? What are you going to put in there? That's a good question, and actually providers of the Servlet API is a good example. They came up with all kinds of versioning schemes, so it became impossible to write a portable bundle that worked with Servlet 2.5, 3.0, 3.1, and so on. So OSGi is solving that by using the OSGi contract capability. So this is a little bit different to what you're used to in the import package range. What you do here is you import the packages that you need without a version. Now, only do this for packages that are, following this contract, this specification. But basically, what you do is you say, I don't know what the version is. I have no idea, but I do know that there's a contract called Java Servlet, and it's 2.5. Now, all of these contracts, at least for the JCP packages, are listed on this website. And what this means is that any version in the future that is still compatible with 2.5 still provides this capability. So if you have a 3.0 implementation, it will provide the capability in version 2.5, 3.0, and if you have a 3.1 implementation, it will add 3.1. So it's kind of a reverse model, but at least using this allows you to write portable bundles that use these packages that come from organizations that don't follow semantic versioning. So more details are on this link here. As I said, most of the JCP packages are enumerated there, and so you can find them there. And implementations are starting to provide these capabilities in their implementation, so you can just start using them today. Now, I know this was a little bit short, but I wanted to stay within the time frame and maybe take a question or two. Yes.
So regarding the annotations and declarative services, are these annotations for build time or for runtime?
So they are build time annotations. Build time.
For build time, so
yes.
Who does the processing of this?
The tooling of your choice, which means, I mean, basically more or less most of the tooling which is available supports these annotations. So obviously BND tools and BND does, and then if you're using Maven and Gradle, it does so as well through. That's the exception, yes. As far as I know, I'm not a PDE guy, but that's what I heard yesterday already. Yes. Yeah.
So why was it on runtime?
It has several reasons, because the DS, Declarative Service Specification, started without annotations sometime, and just to be compatible with that. It also, you don't want to scan all classes at runtime, especially if you're updating bundles and then all these things. And then finally, we didn't really like the idea that you're just deploying classes into the OSGi system, and then automatically something gets picked up. For example, if you're using some open source library which happens to have these annotations in, you have no way to opt out if it's done at runtime, right? So if you do that at build time, it's easier to control all these things.
I guess even if you use PDE, you can probably shell out to B&D as part of your build to process these annotations.
I guess so.
I guess that's.
There are two additional implementations that provide that for BE. It's not integrated, but it's being discussed right now which implementation to take, because the DS specification right now advanced pretty much. So it's a decision to make. But it is there. You can use it within BE, and it's working quite well.
Oh, that's great. That's great.
What is the best approach to inject security management in this new OSGi REST management APIs?
Yes. We couldn't really agree on what the best security mechanism was, but there is a callback mechanism in there that basically, I think it's called handle security, that allows you to plug in your own security mechanism. So yes, it is. It's provided as a hook, basically, to you, where you can write your own.
Is there some tooling available for resolving these dependency problems that arise when you couple several of the components, like you stated? It's a little bit tough to debug that because you have potential services that could provide it, but they are not resolved for some reason. Is there some tooling in Felix to resolve it? Because you have to hop from one service to another, and this is very time consuming, and I wonder if Felix has something to provide that, because Equinox does not.
I think we have another plugin for the web console. I don't remember the name, which does some kind of that, but I'm not really sure how far it gets you. So it's more or less no, except if Ray knows something.
I just want to add to that most of the new specs have a DTO introspection
API,
which is Declarative Services, any of the ones that were updated for R6, part of the updates were to include DTO introspection APIs. So that's not fully fleshed out as far as having, let's say, a commands in Go or UI, but the services are there. Like the HTTP Whiteboard has an introspection API. DS, I'm trying to think if there was the REST API actually just provides some DTO information, but yeah, so that's the mechanism that is generally being taken.
But I guess I expect that tooling is really now coming up, because these DTOs are now new, more or less, right? They are there since 2-3 months, and now you can really write tooling, like you said, based on these DTOs, but it's not there yet.
All right.
Okay, any more questions? If not, I think it's time for lunch. I think they start lunch at 12:15. It's exhibitor time now, so please go out and check all the cool exhibits you can see upstairs, including the train. We start again here at 2:15, and I think you mentioned that BJ will be here this afternoon and go into more depth about all the new goodies in Declarative Services, and that talk starts at 2:30.
Yep.
So, David and Carsten, thank you lots.
Thank you.